welcome to this session with Aleph Zero. It is an amazing opportunity for us to get to know the Aleph Zero team and also to learn from them how to launch smart contracts with Ink. And today our star speaker is Vlad from the Aleph Zero team, who will teach this session and will show us everything that we need to know. This session is also part of the Aleph Zero hackathon that is upcoming in the end of this month. So use this opportunity to really learn how to write smart contracts on Ink, because this is very important, of course, for the hackathon. And this is a learning experience that you will need for the hackathon. I will also ask you, if you have any questions, to put them in the chat here, because we'll use the rest of the time after Vlad's sessions to answer questions. In case we do not have enough time to answer them, we will, of course, take them with us and answer them on Discord. So Prosper will also leave you here the Discord link. If any one of you is not part of the Discord, there is a dedicated channel to Aleph Zero. So in case we have any questions left, we'll answer them on the Discord server. So without further ado, I don't want to waste any more time. Vlad, please, you have the word now.
Hello. So pleasure to see or rather have everybody in this meeting. I today will present some Ink smart contracts basics and also some slight introduction to Aleph Zero so that everybody knows at least where to search for information and well, some basics as well. Let me just share my screen. There it goes. So hopefully everybody can see the presentation and can hear me well. Okay. So yeah, without further ado as well, we'll just go ahead and start. So smart contract, what it is, what to do with it. Generally, without even any ink behind it, a smart contract you can basically define it as a program running on chain. It can do whatever you want it to do. It can be defined as a contract where there's some participants, or you can just do whatever it wants, whatever else it wants to do. There's some neat definition from Wikipedia as well, so you can go ahead and read that. So what are use cases for the smart contracts? Generally everything blockchain connected, obviously. So DeFi's, aka decentralized finance. So yeah, everything in that sphere, digital identities, supply chains, and certificates of ownership. And whatever else you want to build on a chain. And you're actually very much encouraged to think about some unique methods of using the blockchains as well, other than, well, the rest of use cases here. Yeah, and obviously when dealing with smart contracts, you are very much inclined to carefully think about security. First of all, the coding that you're doing, well, it will be public inevitably, but also will be used by a lot of different users who might not have a very positive intent in the end. So at least the basics of security is that you need to validate every single input you receive in your contracts. If you mutate some argument, well, you better be careful about it, and if possible, avoid mutating anything at all. Also, you need to be careful about code which calls upon itself, like recursion or even a contract calling upon itself, or any repeating part of code. So yeah, and importantly, and thing which we'll be discussing later is a catch-all mechanism for um, going through your errors and stuff, and fallbacks and implicit operators as well, operations as well. So the case about specifically fallbacks is the infamous DAO hack. It has been quite a while ago, but I think it still is a good example of why thinking ahead and security is at utmost importance for smart contracts. Uh, so there was this DAO thing on Ethereum, which, yeah, you can basically think of it as a group of investors, and you could basically deposit some stuff and withdraw it without going into much of a financial details. For us as programmers, what is important is well, first of all, it was written in Solidity, and it has this fallback method where if something is undefined in contract's behavior, it will refer to this fallback. And well, if you define something general or undefine the specific behavior, it will just break. And what has been happening with this DAO hack is, well, there's been a lot of controversy. The smart contracts code is public, and people have noticed actually that there are some pitfalls in there and security issues. And while the developers were actually fixing the code after it has been deployed, uh, somebody has made a bad use of it. So we have this user Malice, which is a bit of a pun because the test cases for blockchain user is Alice, and then this very evil sounding Malice. So our Malice first deposited some Ethereum onto this DAO. Now she has the balance of this much Ethereum on the DAO, and then she called for a withdrawal from DAO for this specific amount of Ethereum. And it sounds all right, yes, okay. General operations you do. But what went badly is that this method of transfer later requires for the recipient contract to have basically a receive method, which Malice very maliciously had not. So the contract had to fall back, uh, and the caveat was that the transfer was before actually decreasing the amount of Ethereum Malice would have on the DAO. So transfer goes first. It waits for receive on Malice's side. It sees no receive method. It falls back. The transfer has already been done, but it did not decrease the balance because fallback basically cancels everything. So it has never even come to decreasing her balance, so she can just call it again and again and again and again, and basically run the contract dry of its balance entirely, which has actually happened, and it's been a huge scandal for Ethereum, and they had to do some very questionable stuff in blockchain culture. They had to fork it back, and yeah, it was a lot of unpleasant stuff with a very simple programming mistake. And that is why you need to always think about your code, always think how to make it secure. And yeah, in smart contracts, it is at utmost importance. I cannot stress it enough. Um, yeah, so now a bit about Aleph Zero. Um, it is the company which I represent, and also consequentially is a layer one proof of stake blockchain. It heavily focuses on privacy. It is still being developed, sort of, but the focus is there. And importantly, it has sub-second finality times and extremely low transactional costs. You can see on the slides, it's thousands, 10,000 after the dots. So yeah, it's rather cheap. And importantly, we are using substrate, so consequently Rust environment and Ink as the preferred language for our smart contract. There are some useful links in here. You can check them out. I'm very much encourage you to do so. So the aleph0.org is like the main web page to check everything from aleph0, and there's doc page and developer portal and developer wallet as well on test0. Also contracts UI and for communicating with chain doing transfers, signing stuff, you can use polka.js. Worry not, I think the presentation will be available for you a bit later. Yeah, and everything you can easily find online as well. I just want to make a point that you may and actually are encouraged to search through stuff on the internet. There's plenty of documentation for you to go through if you will ever have any questions on how to do stuff. Okay, so now a bit more about ink. So that's a brief introduction to it. It's an EDSL for Rust. So basically embedded domain specific language, right? So basically it's a subset, I would say, of Rust with a bunch of very useful macros on top of it. Rust being a very cool language with a lot of meta programming stuff enables you to write some very complex macros and then hide a lot of stuff which end users do not necessarily need to see behind these macros. So this is basically how ink was written. It saves you a lot of headache of writing complete code of smart contracts and instead lets you focus on the important parts of the logics of it and stuff. And yes, it is not a separate language. It enjoys all majority of benefits of Rust as well. So yeah, it inherits Rust benefit. It is a modern language. It is type safe as it goes, memory safe as well. It has some excellent Rust tooling, and well, I think a lot of you have heard about Rust. It's universally liked and there's a lot of love on the forums wherever you look up for Rust is just awesome for developers. Yes, and in the end, the ink code you will be writing will be compiled to WASM, which is WebAssembly. So yeah, and it is fast, secure. It can use different browsers, different toolings for browsers and stuff. So yep, it's a short advertisement of ink, and we will proceed further. Yeah, so another popular language which you can use to write smart contracts is Solidity, which is generally used by Ethereum. And really, there's not that much of a difference if you were to transfer yourself from Solidity to Ink. Well, the main difference is it is obviously Rust, so you need to dig up a bit of Rust basics for yourself, for which there's a lot of excellent materials out there. And being just a subset of Rust, you wouldn't actually need the entirety of it. Uh, yep. And other than that, well, there are some benefits in the storage entries, unlike in Solidity where you have 256 bits of storage all of the time. In Ink, you can use variable sizes of storage, which can come in handy really. Can optimize stuff for lower to lower your needs in memory, or use something more complex instead if you feel like it. Yep. So let's see how we can set everything up. It is a bit of a pain to set everything up as ever, but nothing to be scared of. It's very much doable. So you would first need to basically install Rust, Rust toolchain, and importantly also cargo contract palette to be able to build your contracts and stuff. So then you call for this contract palette, you want some new contract, and there's some even templates for you if you want to look them through. There are some excellent examples just to check how everything works. And here's an example. Would use flipper, which is basically flips a Boolean value all of the time. It is commented, documented. So yeah, if you want to check something out, I'd recommend going through that one as well. Um, and well, basically, after you're done coding, you'd want to test it, compile and test it. The compiler might give you some useful hints before that if you have made some mistakes. And they're actually very, very helpful, especially for the beginners when you make some trivial stuff like, I don't know, moving a value instead of borrowing it and stuff, which is not Rust specific, but comes with strong types and memory usage of Rust. Yep, and then you will build it. You might want some actually flag as release or something in here as well. And this build command will result in your binary and metadata stuff, which will then be used to deploy your contract and instantiate it on the chain itself. And there's also the contract bundle, which is basically binary of the contract and metadata bundled into one thing for your convenience. Um, yep. We will look through the entire process of deployment further, so worry not. It will be discussed. Um, yep, there's a Bitcoin as a credit to our tech lead of ecosystem and also the original presenter of the entire um, Ink Basics theme. So hello, Pete. This is an implementation of basically an implementation of PSP22, which is for Ethereum stuff, ERC20. It's a very basic token, which allows you with some very basic token functionality, like checking balance, transferring stuff, allowances. So we will try and implement it just to go through every step necessary, and then we'll deploy it on our test chain as well. Yep, so ERC20 or PSP22 is a common standard for fungible token. You can see some methods in here which need to be defined to follow the standard, like total supply, balances, transfers, allowances. And yeah, that's basically it. Also, a couple of events defined for when stuff occurs. You would actually be able to track through it. There will be some indexed stuff as well, so you can search easily through that. And that's basically the standard, so nothing too scary. Um, so now to write it in ink. Um, Yeah, if you just do the new thingy, it will basically do the entire decoration thing around for you with contract palette. But if you were to write it yourself, you would start with this macro here. It should just basically define some attributes for you. The no STD here means that we will not be using standard uh, library of Rust, and with this wonderful ink contract macro, we will instead be using whatever ink has defined as its standard instead. The reason for it is basically well, you need a lot of specific on-chain calculation, on-chain storage values. There's some decoding and encoding involved in this, behind this uh, everything. So yeah, you would need to redefine standard a bit, and that's all right. So yeah, we also use module, which is something like a namespace from C++ if you're familiar. So you're basically encapsulating a bunch of logic code inside this module for you not to have some weird interactions between other parts of code when it comes to that. Yeah, and basically you use this shortcut of use. So now that instead of writing this entirely in storage mapping all of the time, you can just conveniently call it with mapping instead, and it will just work. Yeah, and here we define the storage with this storage macro. If you define something as inc contract, it will require you to have at least one constructor and storage module, not module, but rather struct, storage struct, and I think also one message which you would be able to call upon. So, yep, here we are defining our storage within storage macro, also deriving the default. This is a bit of a Rust thing, and what it means is basically if you do not provide a value, well, you can call upon the default for every value inside, and it will basically assign it as a default value, which is for primitives generally a 0, and for some sorts of containers like the aforementioned mapping is an empty container. Yep, and struct is your general struct thing is it's something like classes or however else you other programming languages define it. So here we have basically total supply defined as balance, which is inc specific value. I think it's just assigned 126, but covered as balance for more readability. And mapping as balances, which is basically your lovely hash map with account ID as key and balance as the value. And account ID are also assigned on the chain for every account and every smart contract as well. So yeah, we don't need to worry about generating it as well. Yep. So, as I mentioned, we would need an inc constructor. And as we've derived default, we can easily call upon it here as well. And from specific to inc stuff, you can see this um, weird call of self double column, which is basically akin to static functions. And here we would call for the caller and assign it to this variable. A caller is the one who calls the contract. And well, upon constructing the contract itself, the caller is the owner of the contract as well, typically. Yeah, and we would insert whatever we defined as total supply for this constructor into our balances map and basically just return this structure here, this instance of a structure. Oh, and there's a neat shortcut because typically we need to name everything, right? So it would be total supply column and however the total supply is named. But since it is the same name, so you can just avoid or omit the usage of the column here and just pass it as is. This is rather convenient. And yeah, you can define multiple constructors if needed. So there's no problem here at all. Yeah, a bit about Rust memory management. So in Rust is, at least in a safe environment, there can only be one owner of a specific heap allocated piece of data. And you can either move it as if somebody is aware of C++ move notation, or you can borrow it by a reference. So if you were to move it, you would redefine the owner to wherever you move it, and typically it would restrict you from further using this value further down your code. Yeah, so what it does is it allows for some good memory safety and also avoids using some delete implicitly. So yeah, rather cool stuff. Very convenient. Sometimes can be a bit of a pain if you're unaccustomed to this sort of style, but you will get around it quickly. And also, Rust compiler is terribly helpful with that. I mean, yeah, if you were ever to make a mistake with memory management, Rust compiler will probably help you out there. So worry not. Um, yeah, so there's an example of move semantics. Um, in your typical language, so what we're doing here, we have this struct foo with just one field of unsigned 128. We have the function which wants to accept some foo and basically add up to its field whatever plus one and return this instance. So now we're just make this instance here. We want now to pass this instance to this function. And typically, in your beloved other programming languages, this might work. But for us, since we are using move semantics here, we have moved the value to this function. And well, in this function, it goes out of scope. So it basically has gotten deleted. And now you're trying to call uh, this print which wants this field, but well, it's been deleted, so there's no access here, and you will have a compile time error. Mm, yeah, there's the error itself, so you can see freaking compiler gives you like everything. It gives you the line, it gives you what to do, so it is very helpful, especially for these beginner kind mistakes. Um, yeah. Uh, so what we want to do here instead is we want to pass it by reference to borrow it instead. And yeah, and, uh, well, there's another beginner type mistake. Rust very much wants you to strictly and implicitly show if you want to mutate some value. So here you would still stumble upon a small compiler mistake, I believe. Yes. Uh, and it will again be shown by Rust compiler for you conveniently. Hey, you want this to be mutable, so please make this mutable. And yeah, here we just make this mutable, and then we want to implicitly pass it as a mutable reference as well, and everything now just works as a charm. Uh, yep. Okay. So that was some Rust shenanigans for you, real quick. And now we are going back to ink. Uh, well, inc has this inc message macro as well. Uh, and this macro basically tells that the function below it would be public and seen by anybody who wants to access your contract. So if you were to call the contract from the chain, you will be able to access this function. Yep. Oh, and also importantly, for every function, you need to pass this self reference here, and it's basically what I believe Python does as well. It's just an implicit pass of self, which is this in C++, for example. Other languages do this explicitly, like C++ does it as well, but you just do not see it here. It's done implicitly, just in the spirit of being more implicit. Yep, and you can see that we basically implemented the total supply, which just returns the value of total supply for you. And we've also implemented balance off, which would return the balance of the specific account ID for you. And conveniently as well, this get would return an option for you. So if there's no such a pair of account ID balance, for example, in the balances, then it will then with this unwrapped default, you would get the default value instead of getting an error or something. And rather, if you have something to return here, if there is something in the map, it will unwrap it for you and just return the value as balance. Very convenient as well. Yeah, and here's a bit of an infographic for you. It's basically describes what's happening during the transfer. So say we have this Alice, which is no longer Malice, but rather a good user of our chain. And Alice has a balance of 1,000 Bitcoins, and Bob has a balance of 1,000 Bitcoins as well. So Alice want to transfer to Bob the value of 100 Bitcoins. So what would happen is that the balance of Alice in the map would be decreased by 100. The balance of Bob in the map would be increased by 100. Now the transfer is concluded, also sending an event for you and for everybody else to check out. Yep, and here's the code for all this stuff. So do we have here? Yeah, you can notice that it returns the result type, uh, which is basically both OK and the error, depending on whatever you're returning. Yeah, and we're again using this environment caller semantics, so that we're transferring from the one who calls the message to whoever they want to transfer it to, and well, the value of how much they want to transfer it. And you'd notice this ampersand here basically borrows, or not the compiler will kindly remind you to do that if you forget. Yeah, and basically there's the implementation of everything. So we basically do everything which was shown in infographic. If something goes wrong, for example, we don't have enough balance, then yeah, we are returning the error. And if everything goes right, we, in the end, after you know, yeah, that would better to use some safety in here for addition and sum. But yeah, so we're just changing the values inside of our maps. And we're also emitting event and saying that everything's gone all right and okay. And that basically concludes our message. Yeah. So here is how you define these errors stuff. It is also defined in the protocol itself. So the PSP22 will uh, help you with the definition. Everything is in there already. And you would have errors like insufficient balance or allowance, which is basically how much you allow some other person to spend on your behalf. Uh, yeah, and everything else. You can also have some custom uh, errors defined in your contract. Yeah, so this is pretty basic stuff. There's more about the result. So basically, what you have here is that something which is of the type T would be the OK, and something which is of the type E would be the ever, basically. Um, yeah. Uh, Okay, it's just some Rust specific stuff, and you'll get your hand around it rather quickly, and don't worry about it. And here is how we define the event for ink. Uh, so it's also a structure, but we call upon the ink event macro on top of it. So it would know that it's an event, and inside the event, and this value, which would be shown when the event is emitted. And also for those value which you want to be indexed, you would put this ink topic macro on top of them. So, for example, from and to are rather specific values which might be convenient to search upon. So you would want to index them, but the values are typically very chaotic and there's no much sense indexing them. So we are omitting this ink topic top of value. Um, yep. Oh, you can also note that from and to here are given as an option, which might come as a rather strange decision for a transfer, right? But actually, it has a use of being applied during your mints and burns, where obviously, well, maybe somebody in the chat can go further with that. Uh, yeah, but that's generally how you would define an event for ink. Also rather simple. Um, yep, and to emit the event inside your function or message, or whatever you'd like to call it, you need to basically provide it with the values. And as mentioned before, from and to, and as defined in the protocol itself, from and to are options. You need to wrap it into this sum thing, which is also Rust specific. Um, yep, yeah, and also this star thingy is how you dereference the value, so that you would pass not a reference to value, but to the value itself in here, which is important. Uh, yeah, okay. Um, so yeah, you can pay your contract with the native currency of the chain. So all the balances before, all the mappings and stuff, they were in Bitcoins, right? Which is just the native to the contract currency. And you also would be doing this on the chain, which might have, or rather, will have its own currency. And this is how you pay a contract in a native currency for some bills, for example, and stuff. So it's a handy way to do that. You would also call upon this environment here and then just transfer the balance from it. Yep. So after you've done writing the code, a very, very, very important part is that you test the code you've written. And with ink, you do this with this handy ink test thingy. Basically, you would want a bunch of tests, and you would probably want to make a model out of that or whatever. But generally, just for one check, here it goes as an example. Uh, yeah, you will use the test ink test macro. It would have some handy stuff like in kind of test default accounts, where you would have the famous now Alice and others. The Bobs and the company, and you can handily transfer stuff between them, check if everything works as intended, returns the right events and stuff like that. So yes, everything you have written in your code before, you very, very, very much want to test properly with first unit tests and then the E2E tests. Um, yep. Yep. Uh, so yeah, this is how you do the unit test, and with D2E tests, it sort of looks like that as well, but you would be using some E2E tooling on top of that. And the current good stuff, which we strongly recommend you try out, is Drink for the E2E tests. It has some very I don't know how to praise it enough because there cannot be enough words for that. But it basically has both CLI, uh, which can show you some basic stuff, and then you would want to use it as a library. And yeah, I very much encourage everybody to use Drink and to go ahead and see the documentation for it as well for the E2E tests. Uh, okay. So there's some stuff about more on Rust. Um, and as you've seen before, this result thingy, right? So we would here, for example, upon meeting some condition, we'll return an error. And if all goes well, we would instead return that everything is all right and okay. And when we will be processing this stuff, so an inconvenient way to do that would be always go through this match and see if we have gotten okay from this method, and we will basically return this for this match and then assign to this variable, or we will return the error and we'll call upon the panic and we will be shouting out loud. Yeah, so that's terribly cumbersome and inconvenient. So instead of that, in Rust, you would want to use this questions mark instead. So it basically does the same thing. It will unwrap the value for you here if all goes well. If all goes badly, it will return the error for you, and well, you will proceed to do with it however you see fit. Yeah, so that's the better way of calling upon functions which might return an error for you. Basically for everything which returns result. Um, yep. So there'll be some series of screenshots on how to deploy stuff on the net. Yeah, get ready. uh, so that's what you'll see when you want to deploy a contract. You would basically choose your account. You would choose how to name your contract, and you would want to upload your contract bundle, which is generated by the build command we've discussed before, and has this contract dot contract thingy. Yeah, and it will generally be in the folder of your project's target Inc. Yes. So you just upload it in here. You would push the next button. You would probably need to sign this transfer as well with whatever signer you are using. And yeah, the contract will then want to be uploaded. Yeah, right. It's first it need to be uploaded and instantiated. So you would call upon its constructor. You would pass a value which a constructor needs, which for the Bitcoin we were using the construct which wants the total supply value. Um, this would not be in T0, which is the currency of testnet for Aleph0. It would rather be the value of Bitcoins we are using for our smart contract. Yeah, you can add some salt in there, and there's the dry run outcomes for you to see how much gas is used. Uh, yep, and you basically will follow through with that. I'll show everything for you here. And yeah, you will sign the transaction. And here you would be able to uh, call upon the ink messages here. And if an ink message is a simpler getter, you would get the get the outcome right here. Uh, yep. If you want to see everything there is, you would there is you can call upon for the contract. You would address to the contract metadata, which was bundled together when you were deploying the contract. And this is, by the way, is why you very much want to have everything documented properly so that everybody can see what's the method about, what you want to do with the method, what it returns and stuff. So yeah, documentation is important. Um, yeah, but if you want to call upon a method which not just returns a value for you, but also wants to set some stuff, you'd need to uh, basically go through that, and there's a transfer method for you. You would basically pick yourself as a caller generally. You would address it to some account ID. So account ID would automatically go with this convenient interface where you can pick up on some contract ID, and then you would also input the value, which is again not T0, but rather the Bitcoins value you want to transfer, because we're using Bitcoins for these smart contracts. Um, Yep, and then you call upon this message, and it will emit the event for you, where you can see from whom to who and what value. Uh, Not to zero again, but yeah. Um, yep, and to wrap everything up, a bit more about ink tooling. There's wonderful stuff Inkathon, which would be useful for anybody who is dealing with front end, because it has some marvelous examples. Really, you want to look through that if you're doing some JavaScript stuff or whatever, any TypeScript or whatever else you're dealing that with on front end. So that's what I would recommend you to use. And drink, which we do not have a permission to view a video, but it is a tool by Cardinal Cryptography, which is basically developers of Aleph0, and you can find it on GitHub. It's yeah, here's the link. Um, it has some proper documentation and is a very, very nice tool for E2E tests. It basically allows you to do the E2E testing without running the local node, without doing almost anything. It just works and it's wonderful. So cannot recommend it enough. Do try it out. Um, yep, and uh, there's some links for you further, and that would be it from me. Hopefully, everything was clear and enjoyable enough. So I would love to answer the questions now.
All right, thank you so much, Vlad. Thank you so much for this presentation. Now I would like to see what kind of questions we have in the chat. I see, I think 3 questions. All right, so the first question, how does this setup differ from chain to chain? For example, if I'm building with ink for Polkadot, is this the same layout I would use? Just trying to gauge, I don't know how to pronounce that. What is standard versus specific to give to a given blockchain?
Uh, well, if ink smart contracts will be the same from chain to chain, yes. I'm not sure what the question is about. There are some differences in chains, like in gas costs, which you need to, you know, look after, like some block finality times and stuff. But generally, what you get from an ink contract, which is a WASM file, it can be applied to basically anything which is compatible with WASM. So yeah.
All right. Can I build smart contracts completely with Rust?
No.
Okay.
Basically, ink is a subset of Rust, and it uses some very cool macros for you. Well, theoretically, you could implement everything of it on your own, right? But it would be terribly cumbersome, and well, basically, don't use ink instead.
Is the is there any scaffolding repo available for texting with ink that you recommend?
Texting, like exchanging messages. It would basically be some transfer variation, and you would have some message field, I guess. Not sure if there's any library for that. Testing. Well, you have the ink
Maybe
test.
maybe the person
Yeah,
meant
the
testing, not
testing.
texting.
Yes, yes,
Yeah.
yes, yes. Yes, for testing, you have for unit tests, you have the ink test library, which is, well, uh, self-explanatory and been shown in here. It should be enough for your needs. And for E2E tests, I would again recommend Drink.
All right. Please, can you tell us about viable alternative options to Solidity Open Zeppelin implementation for ink?
Uh, not sure I can. uh, why? uh, well, you could ask this question on Discord. Maybe someone more knowledgeable than I would be able to give you
All
some.
right, so we'll take this question to Discord. All right.
Yeah.
Is it possible to do gasless transactions in certain conditions on Aleph Zero?
Now every transaction requires a gas price as far as I know.
Can we use CCIP protocol in ink language and how?
You would want to Google that possibly. And for what purposes exactly?
Okay, so maybe the person who asked that question can elaborate a little bit. All right. Okay, next question. How can we add your libraries, Aleph contracts, palettes to Substrate without incompatible issues? I'd prefer to have contracts in Polkadot.js UI. I do not want to see it presented UI. I'm not sure I understand the question. Do you understand the question, Vlad?
Well, basically, contract palette contracts is part of Substrate, so you you can use it wherever you want. including on the chains which do work with substrate arrays. So it's not Aleph specific, I believe.
Okay, I don't see any other questions for now. Okay, there's one more. Is there only one way to deploy these smart contracts? Can I deploy on chain through AWS?
Mm. Well, we have an API, so you can deploy from wherever you want, basically. You would just be calling upon the API.
Okay, so this one question, can we use CCIP protocol, and how the person elaborated to transfer data through blockchains?
Mm. This might get a bit cumbersome, but if you were to use some sort of bridging stuff, I guess, yeah, but I'm not an expert in here. You would better want to ask this on Discord or just Google this stuff.
Okay, so maybe we can take this question to Discord as well. All right, so I think, okay, so the last person asking question, can you maybe unmute yourself and ask the question, because I don't really understand, and like it, I think your actual question got lost in the chat somehow.
This is Mustafa. I got a question about options. Like we have OpenZeppelin and Solidity. We have something similar for Ink, a standard library for standard implementations, like ARC, etc.
Well, yeah, standard implementations of different protocol like ERC and stuff are PSPs for the ecosystem instead. So you would be just using them. Yeah.
PSPs. We have standard implementation for PS. We have standard implementation for PSPs and in Ink. There is a standard library with standard code pieces that and contract that I just extend if I want to implement an ERC20.
Yeah, basically you would be using a standard implementation of PSP22 for ERC20, and we are currently developing one of our own, which we would recommend to everybody. I think it's already public, so you just Google for PSP22 on Cardinal cryptography. If it's not public yet, it will soon be.
All right, so let's take the last question here in the chat because we're actually out of time. Is there a faucet for testnet you can advise?
Yep, there is a faucet. It's basically testnet
Okay, the
faucet.
person just wrote, I found it. So
Good
they
job.
found it. Okay.
Yeah, so
All right.
on the testnet, the internal token is basically free for everybody to use. You can inquire however much you want via the faucet. So all the gas prices and stuff is covered for you, don't worry.
Okay, perfect. Yes, thank you so much, Vlad, for answering all these questions. Thanks for everyone who participated and asked questions. This session was recorded, so it will be made available on our YouTube channel very soon and linked to the landing page of the hackathon. I want to remind everyone that we have an upcoming hackathon with Aleph Zero starting in the end of the month. I will drop the link here to the hackathon. So everyone who participated here tonight is welcome to join the hackathon and build on Aleph Zero. We're extremely looking forward to what projects will come out of it and to be working together with the Aleph Zero team. Who also will support the winning teams after the hackathons if they want to continue building their projects. So thank you everyone again for being with us tonight. And for all the questions that were not answered here, we'll take them to Discord. and the Aleph Zero team can answer them there as well. Yeah, so thanks very much for everyone, and have a great evening.
Thank you. Ciao.
Thank you. Bye bye.